So today's topic is playing with numbers. The first concept in this topic is factors and multiples. So what are factors? Factors are the numbers that you can multiply together to make another number. So for example, 3 into 4 is 12. So 3 and 4 are factors of 12. So we can get many such examples. For example, 5 into 7 is 35. So 5 and 7 are factors of 35. Okay. So now, what is a multiple? A multiple is a result of multiplying a number by an integer. Okay. If you multiply a number by the fraction, it's not a multiple. To get a multiple, you need to always multiply the number by an integer. So given example is 14 is a multiple of 7. Why? 7 into 2 is 14. Now 2 is an integer. So 14 is a multiple of 7. In fact, the tables which are learnt are the multiple tables. So whenever you multiply a number by an integer, you get a multiple. Now 36 also is a multiple of 6. Okay, sounds good? So let's move on to the next concept. Hcf and Lcm. Okay, so what is Hcf? Hcf is the highest number that divides evenly into two or more numbers. Now that we know what factors are, if I take two numbers, they may have a lot of common factors, right? So among those, the highest common factor, the largest common factor is the Hcf. So it is the largest number possible to simplify those numbers. Make sense? Okay. So let's just understand this concept a little better with an example. So what is the Hcf of 12 and 16? So what do? I write down the factors of 12. What are the factors of 12? 1, 2, 3, 4, 6 and 12. We can find this out by simple divisions. Now what are factors of 16? 1, 2, 4, 8 and 16. So I have two sets of factors of 12 and 16. Now what are the common factors of this? I have 1, 2 and 4. 1, 2 and 4 as the common factors. Now what is the highest among 1 to 4? It's 4. So the Hcf of 12 and 16 is 4. Okay. Let's move on to the LCM. Now, if I am given two numbers, the two numbers can have any number of common multiples, right? With two numbers, I can have any number of common multiples. Among those common multiples, the lowest common multiple of two or more numbers is called the LCM. So LCM is abbreviated to lowest common multiple. Let's understand this better with an example. So the multiples of 4 and 5. Let's see. What are multiples of 4? Which is a multiple table, right? So multiples of 4 are 4, 8, 12, 16 and 20, 24, so on. Right? Now what are multiples of 5? 5, 10, 15, 20, 25, so on. Right? So what are the common multiples among these? I can find 20 to be a common multiple. So that is the lowest common multiple for both the numbers. Okay. So what is the LCM of 4 and 5? It is 20. Okay. Sounds good? So let's move on to the next concept. So now when we are given two numbers, we may naturally be, we may naturally want to know how to find the HCF, because it's not possible to write down all the common factors and just see what are the common and which is the highest among those. So for that, we use the short division method. Which method? Short division method. So let's see what do we do in the short division method. Given is the first step to divide both the numbers by a common number until none can be found. Okay, so if I'm given two numbers, I divide the numbers by common numbers until there are no more common numbers, common factors. Then I multiply the left column in the second step. The left column consists of the numbers that I have divided both the numbers by. So for better understanding, let's just see the HCF of 96 and 144 as an example. Right? So I'm going to write 96 and 144 side by side. When I see these numbers, I feel that 2 is a common factor because obviously it's an even number. So I divide both the numbers by 2. Then I get a remainder of 48 for 96 and 72 for 144. Okay. So I write 2 on the left column and write 48 and 72 below the numbers respectively. Again, I see 2 as a common factor and I write 2 on the left column again and I divide 48 and 72 by 2. So I get 24 and 36. So this process I'm going to continue. I'm going to divide all the numbers with common factors until there are no more common factors left. So in this case, after dividing everything, after dividing all the numbers by common factors, I'm left with 2 and 3. Now 2 and 3 don't have any common factor, right? So I stop the process there. Now what do I need to do? I need to multiply the left column. So the leftmost column I have to multiply to find out the HCF. So in the left column I have 2, 2, 2, 2 and 3. I'm going to multiply all these numbers, just 2 into 2 into 2 into 2 into 3 to get 48. So HCF of 96 and 144 is basically 48. Okay, sounds good? Let's see the next concept then. The next concept is of the LCM short division method. Again, we can't just write all the multiples of two numbers and then find out the common multiples, right? So what do? We apply the short division method. Let's see what the first step is. The first step is to divide both the numbers by a common number until none can be found. So just now as we did in the HCF short division method, we divide both the numbers by common number until there are no more common numbers left. Okay. Now in the second step, we multiply the left column and the bottom row. What did we do in HCF? We just multiplied the left column to get the HCF. But now in this case, we are going to multiply the left column and the bottom row to get the LCM. To get a better understanding, let's just check out an example. The example given is to find the LCM of 24 and 60. Right? So again, I'm going to do the same. I'm going to write 24 and 60 and I'm going to divide it by 2. I'll get 12 and 30. Again, I divide it by 3. I'm going to get 4 and 10. I continue this process until I'm left by 2 and 5, which have no further common factor. Right? So this particular table is what I get. Now what is it given? To multiply the left column and the bottom row. Okay, so what do we have in the left column? I have 2, 3 and 2. What do I have in bottom row? I have 2 and 5. So to get the LCM, I need to multiply all of these numbers together. So what is the LCM? 2 into 3 into 2 into 2 into 5. Okay, which gives me 120. So LCM of 24 and 60 is 120. Okay. Now let's go to the next example. Concept. Rules of divisibility. So what is divisibility? Divisibility is the ability to determine what numbers a larger number is divisible by evenly. So when I see a number, my ability to examine if it is divisible by 2 or 3 or any 40 or anything, that ability is called the divisibility. Sounds good? Now, naturally, if I'm given larger numbers, I get the doubt as to which number is going to divide this. So for that, there are certain rules of divisibility to make the divisibility tests, which can give me an idea of which number can be divided by which one. So there are some tricks that we can use to help us determine what larger numbers are divisible by without doing long division. Instead of doing long division every time, we are going to just use these rules of divisibility to find if it is divisible or not in a short and quick way. Let's see the rules of divisibility. So the first rule is for 2. To check if a number is divisible by 2, what do? We check if the units place is even or not. Right? So if the units place is even, the whole number is going to be divisible by 2. The second thing is divisibility of 3. Now listen to this very carefully. A number is divisible by 3 if the sum of the digits of the number is a multiple of 3. Okay, so let's just take an example. Suppose I have been given 342. So instead of doing the long division method and seeing if the remainder is 0 or not, I do a simple trick. What do? What are the digits of 342? 3, 4 and 2. I just add 3, 4 and 2. What do I get? 3 plus 4 plus 2. It's 7 plus 2, 9. Is 9 divisible by 3? Yes, obviously. So the number 342 as a whole is going to be divisible by 3. Okay, sounds good. Now let's check out another example. Suppose 956. Let's say I'm given 956. What do I do to check the divisibility? I add the digits of 956, which is 9 plus 5 plus 6. So what do I get? I get 20. Is 20 divisible by 3? No. So the number is not going to be divisible by 3. As simple as that. Sounds good? Okay. So for 4. How do I know if a number is divisible by 4? If the last 2 digits are divisible by 4, the number as a whole is going to be divisible by 4. So if I'm given a large number, to check if it is divisible by 4 or not, I do this simple thing. I go and check the last 2 digits of the whole number. If the last 2 digits are divisible by 4, I know for sure that the whole number is going to be divisible by 4. Let's take an example. 456. Sounds good? 456. I check out the last 2 digits. What are the last 2 digits? 5 and 6, which is 56. Right. So I check if 56 is divisible by 4 or not. I know that 56 is going to be divisible by 4. So I can say that 456 as a whole is going to be divisible by 4. We can apply this rule to any large number possible. We have to just check the last two digits of the given number. It can be any length number. Okay, sounds good. So the next divisibility rule, which is for the number 5. A number is divisible by 5 if the ones digit is 0 or 5. So we've been noticing this even in the 5 table. If the last digit of the number is 0 or 5, we know for sure that the number as a whole is going to be divisible by 5. Okay. The next rule is for 6. So how do I know if the number is divisible by 6? 6 is 3 into 2, right? So if the number is going to be divisible by 3 and by 2, I can say that the whole number is going to be divisible by 6. Okay. So what do I check? I check if the number is an even number to see if it is divisible by 2. Then I add the digits. I check if it's a multiple of 3. Then I can say if it is divisible by 2 or 3. And if it is divisible by both, divisible by 6. Okay? Sounds good? So the next rule. For 7. 7 divisibility is a little typical. So please pay attention. I can say that a number is going to be divisible by 7 if I take the last digit and I double it and then subtract it from the rest of the number. And if the result is going to be divisible by 7, I'll say that the number is divisible by 7. Okay? So what do I do? If I'm given any number, I see the last digit. I double it. Then I remove the last digit and subtract the doubled number to the rest of the number. Whatever result I get, if it is divisible by 7, the whole number will be divisible by 7. Let's check an example. Suppose the number I'm given is 343. So what is the last digit? The last digit is 3, right? So the double of 343 is, the double of 3 is 6. Sounds good? So I'm going to take this 6 and subtract it from the rest of the number. Now that I have removed 3, the remaining number is 34. So I'm going to subtract 6 from 34. What am I going to get? I'm going to get 28. Now, is 28 divisible by 7? Yes. So 343 is divisible by 7. Okay. Next, let's check the divisibility for 8. I can say that a number is divisible by 8 if the last 3 digits are divisible by 8. Let's check this out. So, if I'm given a number, I check the last 3 digits. If I know that the last 3 digits are divisible by 8, the whole number is going to be divisible by 8. So if I'm given, suppose a 4-digit number, I just check the last 3 digits, and if it is divisible by 8, I say that okay, this 4-digit number is going to be divisible by 8. Okay, fine. Sounds good. Now for 9. 9 is going to be just similar to 3. So to check the divisibility for 9, I need to add the sum of the digits of the number. If the result is divisible by 9, I can say that the whole number is going to be divisible by 9. It's similar to 3, but what I'm going to check? I'm going to check if the sum is going to be divisible by 9 or not. Okay? Sounds good? Now let's go for the next rule. The next rule is to check for the divisibility of 10. We know this. What do we know? I know that a number is divisible by 10 if the last digit is 0. Right? Even in the multiple table we see. 10, 20, 30, 40. All this, the last digit number is 0. So if the whole number, however large the number is, if it is ending by 0, I can say that the whole number is going to be divisible by 10. Okay, I think it's simple. Let's check for the divisibility rule of 11. This is the final rule. This is also a little complicated, so please pay attention. I say that a number is divisible by 11 when the sum of the odd number digits is subtracted from the sum of the even number digits and the result is divisible by 11. Okay. So what does he say? It says that if I'm given a number, what do? I know that the first place, second place, third place, I'm going to see the places of the digits in that particular number. I take the odd number digits and I add them. Then I take the even number digits, the second place, fourth place, sixth place, so on. Then I add all of them. I add all the even number digits. I subtract the sum which I got from adding the odd digit numbers to the sum of the even number digits. Then if the result is going to be divisible by 11, if after subtracting the odd sum with the even sum, if I get the number which is divisible by 11, I'm going to say that the number is going to be as a whole divisible by 11. Let's take a simple example. 1331. 1331. What is the first place? 1. Second place? 3. Third place? 3. And again the fourth place? 1. So what are the odd number? 1 and 3. 1 plus 3 is 4. The even number is 3 and 1. So again 3 plus 1 is 4. I got 4 in both the cases. Now what am I am going to subtract the even odd sum to the even sum. So I'm going to get 4 minus 4 is 0. And 0 is divisible by all the numbers. Right? So I can say that 1331 is going to be divisible by 11. It can happen to any length number. I need to just check out the odd numbered places and the even numbered places. Okay, sounds good? So now we have reached to the end of the chapter. Thank you.